Okay, so this is the thing. And I ask you to key into your calculator this one as y1. You key in this one. So your y1 is your fx. Then I ask you to key in your y2 as this. This is your f prime x. And your y3 as this. Am I right? Hello, everyone got that in your calculator? Okay. And the part E, I ask you to sketch the graph. Yep. I know the shape of fx is like that. Right? So, if I want to get my fx sine diagram, so what I need to do is I need to find the x-intercept, correct? So how to get the x-intercept for this one? So I put square root of x ln x equal to 0, right? So this is your fx. So there are two possibilities, square root of x equal to 0. So x equal to 0, this is not the solution. Why? Do you know why this is not the solution? Everyone, can you tell me why? Kevin, can you tell me why? Yeah, someone have answered me, not the solution because x equal to 0 is not part of the domain. So ln x equal to 0. So x equal to e to the power of 0. So x equal to 1. So it happened at 1. Okay. So how to know the sign for the region? You have to go to your y1. Can you everyone tell me what is the sign? Hello? Okay, can someone tell me what is the region, what is the sign for region A here? Carisha Lini?
Negative.
Negative, good. You see, you are very well prepared, that is good. Okay, region B, Carisha Lini?
Positive.
Positive. Okay, so now when we sketch the graph, correct? Okay, I'm going to explain to you one by one. Huh? Okay, you know you can get it from the calculator straight away. So before I sketch the graph based on this sign diagram, I'm expecting. So now what I'm expecting, so this one, I'm going to use blue. This one, I'm going to use black. And this one, I'm going to use red, okay? Okay, so when I draw the graph, I know that for the blue one, the fx, so I prepare the axis first. So for the blue one, I know it cannot be equal to 0. So I know that for blue one, this is the 1. So I know you will pass through this point 1. So this part of the graph is below the x-axis and this part is above the x-axis. That's how you imagine. If the sign diagram, the sign is negative, that means the graph is below the x-axis. Are you clear? Student, are you okay? So that is why we draw a sign diagram before we go to the graphic calculator so that it can give us a better picture. Okay, now, are you okay? So then for the black one, I know that this part, that is, it will pass through this point, 0.135 roughly, okay? And this part is below the x-axis and this part is above the x-axis. Are you okay so far? And for F double prime, it will pass through this point also. Yeah. So I use different color so that you can see. And this part is above the x-axis and this part is below the x-axis. So now you get what I mean? So that is how we interpret from the sign diagram. And if they give us a graph, we want to interpret the sign diagram, we also put it down there. Are you okay? So far? Okay, now everyone go to your graphic calculator. Okay, we know that the important point is around here. Okay, the stationary point. This is the stationary point of fx. This one. Okay, is the stationary point for fx. And this is the inflection point for fx. Yeah. And listen, this one, x equal to 1 is the x coordinate of stationary point of graph y equal to f prime x, correct? That means you know that. And if I draw the black color graph, so how I know? It will go down, go up, stationary, come down. This is your f prime x graph look like. Okay, so that means your f prime x graph got stationary point and it's a local maximum. Hello? Class, are you okay? Okay, so now you go to your graphic calculator. So this one need a lot of your thinking, whereby you have to relate. Okay, can you go to your graphic calculator? Okay, you have all this in your graphic calculator, on your graphic calculator, correct? Okay, now go to window. Your important point is cluttered around 0 and 1. So we put the window minimum as 0 and maximum as, maybe you want to put 1.5 or maybe you want to put 2. And make sure all these equations are highlighted. All the 3 are highlighted. Okay. Okay. You can put 2. Okay. After that, you go to zoom fit. You have to wait for some time. You have to wait for some time. Okay. Is your graph come out already? Sandia, is your graph out?
Yes, Miss, already.
Okay, it look like you can't see this part clearly, correct? Okay, Sandia, can you send the graph show by your graphic calculator to the chat group?
Oh, okay, Miss. Let me get my
So
phone.
that, yeah. You get your phone first, or you put your phone very far away.
Yeah.
Actually, that is good. So that no one disturb you. But sometimes we need to use it, okay?
Miss, I send in the group chat, is it?
Okay, yeah, send in the group chat.
Okay.
Okay, you see the graph looks something like that, correct? Okay, so if the graph looks something like that, you can't really see the important point of it. So what we do is, class, what we do is you go back to your window. Still remember? You go back to your window, then you change your Y minimum and your Y maximum. Okay, Sandhya, can you tell me what is your Y minimum?
Mine is -10.
-10, okay.
Yeah.
So now we don't want this. It's too low. So we put it to, change it to, okay, Sandhya, you just suggest to me a reasonable number.
-2.
Okay, -2, can. Okay, how about your Y maximum? May I know what is the value?
10.
Also 10.
Yeah.
Yeah. So now you go to, what number you want to change to? You can see from the scale that you have just now.
Maybe 5.
Maybe 2,
5.
5. You want to change to 5. If you look, if you look at the one, if you look at your handphone, you look at the picture that you sent to us, you look at the scale, correct? 1, 2. So the turning point of the red graph, this is your red graph is your f prime x. So it's very low. So if you go up to 5, then you can't see the picture clearly. So make a better choice.
3 or 2.
3 or 2. So we shall choose, 2. We choose 2, okay? So we change it to 2. Okay, then after this, after you finish this, you press the one called graph. Then it will take some time. Everyone, can you please? Then I will ask someone else to send me the, okay, it will take some time for the graph to appear. That's why sometimes graphic calculator can't really give you a nice shape of the graph. So we have to exaggerate it a little bit. So afterward, you see how I'm going to show you how I sketch, huh? Okay, I will snapshot from mine and give it to you. Okay, yours may be a bit different from mine because the range that I use is a bit different. Okay. Okay, do you see mine? Okay, so now I'm going to show you how I make a bit of exaggeration on the way we sketch the graph. Okay, because we want to show the feature of the graph. So I'm going to delete off all this part. So I'm going to sketch the f prime x, fx first. Okay, look, there's blue. Okay, I know that my fx will turn here. There's a turning point here. Okay, and the coordinates of turning point, you have found that is very, very small. So when I do, I know that it cannot be equal to your, and I know there is an x-intercept at here. There's only one x-intercept. So the graph actually, it doesn't touch here. It go a bit like that. Then all the way here is concave, concave upward. See or not? So here I will make a knot here because x cannot be 0 and cannot be the other side. Are you clear? So then after that, it go concave. See or not? So this is your y equal to fx graph. Okay. So are you okay so far? Okay or not? Okay, now if you look, I label the point. This is my point A, B, and this is my point C. Okay, and this is my stationary point for fx. Okay, this is B, this is C, and this is D. Okay, now, if you look at the graph, A to B, my fx is decreasing with decreasing rate. Okay. So that's why the value of your f prime x, okay, the one I am going to do it in black. So you see, decreasing with decreasing rate. That means it's from very negative to less negative. The word decreasing gives you the idea that the graph is, the value is negative. The value of f prime x is negative. So it starts from very negative to less negative. That's why the graph goes in this way and becomes 0 at this point. Okay? Are you okay so far? Then, okay, I'm going to go to the next one. Then from B to C, fx is increasing with increasing rate. Okay, so that means f prime x is the rate. So it continues to go up. Yeah, increasing means the value of f prime x will be positive and the value become more and more positive. That is the meaning of increasing rate. So it go up like that. So until here, okay? So after that, from C to D, fx is increasing with decreasing rate. That means it is positive and it approaches 0. Okay, it is positive but become less and less positive. So that's why the graph of f prime x start to go down. Are you clear? So that means, in conclusion, I can say that at x equal to 1, fx is increasing at the fastest rate. So that is also another meaning of the non-horizontal inflection point. So if the question asks for fx increasing at the fastest rate, then you have to look at the inflection point or the x coordinate of the stationary point of f prime x. Are you clear? So is sound okay here, correct? Okay, so we have done with our y equal to f prime x. So far, any question? So now we go to the next one, our f double prime x, the rate of change of the rate of change. So we know that this part is positive because fx is concave and it will pass through this point. So I'm going to use the red color. So it's positive. If you look at your graphic calculator, okay, it goes from here, come down, and it approach 0 here. That's how you go. Okay. So you see, graphic calculator sometimes can't really give you a real situation of it. Okay. So this is your y equal to f double prime x. So from these three sign diagram. So from here, I hope you can go through by yourself the conclusion. Okay. So I'm going to go through another example with you so that we get the idea of what do you mean by stationary point of a function? What do you mean by inflection point of a function? Are you okay? You need to go through it a few times, and you have to have your own idea. Okay, shall we? Shall we get into the next one? Okay. Yeah. So another example. Okay, we will start now. I will give you the example. Given fx is equal to negative x e to the power negative 0.2x. Okay. A, draw the sign diagram of y equal to fx. Okay. B, you can straight away key into your graphic calculator this thing. So you just need to change your y1. Your y2, y3 don't have to change. Okay. Find f prime x. Hence, find the coordinate of the stationary point of y equal to fx and state its nature. Okay, C, find f double prime x. Hence, find the value of x when fx, y equal to fx is decreasing at the fastest rate. D, sketch the graph of y equal to fx, y equal to f prime x, and y equal to f double prime x on the same axis. For x between 0 and 10. No, 10 is too small. 15. Please, increasing. Okay, so Miss Do have to go into it as fast as I can because I have 20 minutes left to explain the whole thing. So you can watch through the video again. Okay. So for part A, you want to draw a sign diagram of any function, correct? So you put fx equal to 0 first. So negative x e to the power negative 0.2x equal to 0. So we know that negative x equal to 0. So x equal to 0. All right. So e to the power negative 0.2x equal to 0. There is no solution here. So everyone should be very familiar with that. So x can be any value. Yep. So this is your fx sign diagram. Okay. So when x is positive, so you can use your graphic calculator. You call out y1. So this one you get positive. This one you get negative. Okay, so I'm not going to repeat how to use a graphic calculator to help. Everyone should know by now. Can I assume that? Yeah, Bram, can I assume that?
Yes, Miss.
Okay, so then we go to part B. Okay, part B, your U is negative X. Okay, so your U prime will be -1. Your V is e to the power -0.2x. So your V prime for exponential, you just copy down the whole thing. Then you time by the derivative of the power, which is -0.2. Okay, then you put into the formula of product rule. Okay, e to the power -0.2x times -1 plus -x times -0.2 e to the power -0.2x. Okay, so their common factor, factorize it out. Okay, so we have e to the power -0.2x, open bracket, -1, both are negative. This one times this one, yeah, both are negative. So I get positive 0.2x. Okay, so you want to find the stationary point, means what? Stationary point of fx means stationary point of fx means f prime x equal to 0. So that is the meaning of the word stationary of fx. So e to the power -0.2x times -1 plus 0.2x equal to 0. So e to the power -0.2x equal to 0. This is no solution or impossible. So -1 plus 0.2x equal to 0. So 0.2x equal to 1. So x equal to, you can use your calculator, 1 divided by 0.2 is 5. Okay. Everyone okay so far? So when x equal to 5, so f5. So you want to find the coordinate, you must have the y coordinate as well. So equal to -5 e to the power of -0.2 times 5. So you have -5 times e to the power -1. Am I right? Okay, so it's -5 divided by e. So if I want to know the nature of the stationary point, what must I do? Yeah, what must I do? Sebastian?
dy dx equals 0.
No, I want to know the nature.
Oh, nature. Sorry. You draw the sign diagram.
Sign diagram of what? Sebastian, you have to be very clear. Sign diagram of what?
You got the 5. You draw the
No, sign
diagram.
diagram of which function? Fx or f prime x?
Oh, f prime x.
Yeah, you have to mention, especially this chapter. So if you want to know the nature of the stationary point of fx, you must draw the sign diagram of f prime x. So we have to be very specific. So you have to draw sign diagram for f prime x. So when we want to draw a sign diagram for f prime x, we know what is the x value that make the f prime x equal to 0, correct? So we mark it down. Then we use our graphic calculator to help us to get the sign. So for this one, this is negative, and this part is positive. Am I right? So you use your y2. Your y2 is f prime x. Everyone got it? Yeah, Chunyi, are you okay?
Okay,
Sure.
sure.
My sign is correct. Ah?
Oh, you ask.
Yeah, I'm asking you whether the sign that I put down is correct or not. I can
Uh,
purposely put it wrong one now.
Wait, I need to count.
So you are not counting when I'm talking.
I counted
Okay.
but not finished.
You don't have to copy. You just need to listen, because after that you can screenshot this straight away. Then you can slowly go and write down your notes as a practice again. Hello? Okay. So that means, look, my fx graph. So my fx graph, I use blue fx graph. Okay, so negative means go down. Stationary, go up. So therefore, this is local minimum of y equal to fx. So you see, in this case, I keep writing down which function I'm talking about. Local minimum of y equal to fx is 5 and negative 5 over e. Okay, so I'm done with part C. Part B. Are you okay? So now I'm going to do part C. So part D, I expect you to do it as a homework by yourself. Then you can start to do exercise E, B, C, D in chapter 3 already. Okay, part C. So now I'm going to differentiate it another time. So this is my f prime x. Okay, I put it as 1 minus a 0.2x minus 1. Okay, easier for me lah. So it's up to you. Okay, so now my u is e to the power negative 0.2x. Okay, my v is 0.2x minus 1. So it's still using product rules. So I just be patient and write it down properly first. Okay, and your v prime. Okay, Chunyi, what is v prime?
Uh, 0.2x minus 1 bracket.
What is v prime? V prime, v prime.
Oh, 0.2.
0.2, thank you. Okay, Asfindaran, what is my f double prime x now? You see, the moment I call you, I know it. Asvindaran, please stay focused in class. If
I'm
not,
trying to stay focused, but I just can't do all this other stuff, miss.
okay, don't get angry with
No,
me.
no, not angry, miss. I'm not angry, miss. Sorry.
Don't get angry with me. Study is your responsibility. Teaching is mine. So I try my best to go as slow as possible. Okay, V U prime negative 0.2 e to the power negative 0.2x. This is V U prime plus U V prime. Okay, so we do the same factorization.
Okay.
You even can factorize out 0.2 if you want to. Okay, so I factorize out 0.2. I factorize out e to the power negative 0.2x, open bracket, 0.2x minus 1. And here I put then negative 0.2, minus 1, right? Because I take out 0.2. So plus 1, close. So this factorization, you just have to do it. Okay, you cannot say I'm not good in maths. You have to practice until you can. So multiply it out, negative 0.2x plus 1 plus 1. So from here, we have 0.2 e to the power negative 0.2x and negative 0.2x plus 2.
All right.
So this is your f double prime x. Okay. So now, when the question said, increasing at the fastest rate, when you have this statement, okay, class, the moment you have this statement in your question, you straight away know that you have to put f double prime x equal to 0. Okay, that is the situation. When f double prime x is optimum, yeah, when f double prime, when the rate of change is the rate of change is optimum, that is where the function is changing at the fastest rate. So now from here, I'm going to copy down on the next page. My f double prime x is equal to 0.2 e to the power negative 0.2x negative 0.2x plus 2. So that means increasing fx. Okay, so I better write down fx is increasing or decreasing at the fastest rate when f double prime x equal to 0, okay? So now I put 0.2 e to the power negative 0.2x negative 0.2x plus 2 equal to 0. So 0.2 e to the power negative 0.2x equal to 0. This is no solution. Negative 0.2x plus 2 equal to 0. So is 0.2x equal to 2. So x equal to 2 over 0.2, which is 10. So it happened at when x equal to 10. So your conclusion, fx is decreasing at the increasing, sorry, why I keep increasing for this case, is increasing at the fastest rate when x equal to 10. And I also can here, so I have answer part C, so this is extra. So I also can say that at x equal to 10, the rate of change of y equal to f prime x is minimum. Do you know how I know this? Because I can draw the sign diagram of f double prime x. 0. No, not 0. What should I put? 10. Right? Here I put 10 because f double prime 10 is equal to 0. So here is a positive and here is a negative. So from here, from the side diagram of f double prime x, I also can make a conclusion of my what? Of the shape of my fx graph. So I will say from here, shape of fx graph is concave upwards. That is like this for x less than 10 and concave downward for x greater than 10. So concave downward can be half of it only. Yeah. So my fx graph, actually fx graph from here, after you plot, you will see like that. At the inflection point here, then you go like that. Okay. So I will see you on Monday for all this graph. So please go through these two examples thoroughly and study the nature, how each graph affect the others. Are you clear? And whoever want to try the curve property question, please go to the Times. I got question upload there, talk about curve property. Are you okay? So you really have to work hard, huh? I don't expect you to understand everything, just listen to me for once. So now you have the advantage of recording, so you can go through it again and again until you get all the points. Okay, thank you, class.
Thank you, Miss.
Thank you.
Miss.
Thanks, Miss.
Thanks.
Yes.
Teacher,